So, all right. So we looked at those basic rules of fractions, and you had some homework. Are there any questions about any of those that you have?
The whole numbers throw me off.
Okay. Remember that anytime you have a fraction and a whole number, the fraction rules always have to take over. So, for example, if you have 5 times 1/4, how would I make the whole number turn into a fraction? Just by putting it over 1. And then just follow the rules. Was it that kind of thing that was throwing you off, or was it when you were doing the mixed numbers?
When I did
Like you have 5 over 2. That kind of thing. So,
when I try and get the answer, I typed it in and it was wrong.
because they wanted you to use a mixed number? Okay, so like this is what's called an improper fraction because the numerator is bigger than the denominator.
Yeah.
So what you do is you take your numerator and divide it by the denominator. Okay? All right. 2 goes into 5 how many times? So be careful. 2 times, yeah? 2 times 2 is 4. Remember, you're just doing the long division, so subtract 5 minus 4 gives you a 1. Well, 2 won't go into 1, will it? So that's the remainder. So this part becomes the whole number, and this part becomes your new numerator. And this thing just stays the denominator, right? Because that was your original denominator. So this would be 2. What's your numerator? 1. And what's your denominator? 2. All right? So just basically, no matter what numbers you have, you just do the division. Okay? 15 is bigger than 7, so we want to take 15 and divide it by 7. 7 goes into 15 twice. 2 times 7 makes 14. When you subtract that, you get a 1 left over. Right? This part becomes is the whole number. This is the numerator, and the 7 stays the denominator. So what's this going to be as an as a mixed numeral then?
Yeah.
2 and 1 over 7. Right?
Don't raise it.
Okay? And those parts always stay there, always the same. Okay? All right. Also remember, they're building me Blackboard shells so that y'all can look at these videos over and over again. They did not have them done before the weekend, and so of course, you know, the holiday there, everything was closed, so I couldn't fix it then. But these videos will be available hopefully today. If not today, then tomorrow. But I'm really hoping they're going to be available today because we're going to be looking at a topic that causes a lot of trouble for students, where it doesn't have to though, as long as you follow the rules, right? Be careful and try to remember that most of the time when students land in developmental or they decide that they're not math people, it's not because that you're incapable of learning math. It's because the way you were taught just didn't click with you, right? So that's why we're not going to we're going to look at examples, certainly, because you need to be able to make them work, but we're going to look more closely at the method. So you've got to make sure that you change the way you study. You've got to think about studying the method and not just looking at the problems. Because if you learn by examples, every time a problem is done, it looks different than the last one, right? But if you learn the steps, I never ask one question differently for any problem I ever do. If I'm multiplying with fractions, I always first do what? Reduce any numerator to any denominator, and then I just multiply how? Straight across. And if you know the process without having to think about it, if you have that memorized, then you can sit there and think about, wait a minute, what's the biggest number that divides evenly into 14 and 28, right? It's because most of the time, people aren't as comfortable with the mathematics behind it, but if you know the steps, then you can sit there and think about the numbers, right? But if you don't know either one, that's when you just feel totally lost. So make sure you learn the method. All right. Well, today what we're going to do is we're going to look at how to add and subtract fractions. Now again, this is the one process that causes the most trouble when working with fractions. And the reason for that is because before you can add and subtract fractions, you have to set them up and get them ready to add or subtract. Because remember that when you have a fraction, 2 over 3 for example, that literally means 2 divided by 3. So keep in mind that the reasons fractions don't behave like numbers is that they're not numbers. They're actually division problems. Okay? Can someone get that door for me, please? So when you have a division problem, you can't expect it to behave like a 2. Yeah? It's got to follow its own rules. So what we're doing is we're combining two division problems. And the only way to combine two division problems is, notice it does say add or subtract. It doesn't matter which operation. Adding and subtracting, we're going to use exactly the same process. They don't change. And many of you have learned how to line them up one above the other and do it that way. And that process is fine. If you already add and subtract fractions without having any difficulty, perfect. Use your method for a bit. But for those of you who can't make the answer happen every single time, I'm going to show you another method that you can give it a try. Now look, what have you got to lose? If you can't make the other method work, then is it really going to hurt you to try a new method? Okay? And the method that I'm going to show you, we can also make it do a lot more things further on the road. Right? So if you'll learn this pattern now, even if you already can add and subtract fractions and don't have a problem with it, if you'll learn this pattern now, then later we can expand it and use it more. And I really think it's going to make a difference to you. It's really a good pattern. So what we're going to do in order to add or subtract fractions, the first part of adding and subtract fractions is that you must have an LCD, which stands for least common denominator. Now, there are lots of methods for finding LCD. I don't care which one you use. It makes no difference at all to me what method you use for finding the LCD. I'm going to show you one that I think is about the easiest thing you could possibly do. But if you don't like it and you already have a method, fine. Who cares? If you do like it, then use it. So to find the least common denominator, what that means is, if the least common denominator, think about what this means. The denominator, of course, is which part of the fraction? The bottom number. If you're looking for the least, that least means smallest, right? Okay? And if something is common, that means it occurs everywhere, right? Okay? So what we're looking for here is the smallest thing. Now, it's going to be a number in these cases because remember, we're working in the arithmetic review, so we don't even have algebra yet. Okay? The smallest thing that every denominator will divide into. So be careful. It's not what will divide into them, it's what they will divide into. Now think about what that means. What's the smallest number that any number will divide into? Itself, right? Okay? Every number divides into itself, and that's the smallest number that it will divide into. Now that's not the smallest number that will divide into it. What's the smallest number that will divide into every number? 1, right? But that's the other way around, right? We're thinking about what these numbers divide into, not what divides into them. So if the smallest number that you can possibly use is actually going to be the biggest number you have. Okay? Because you have to have something that they'll all divide into, including the bigger one. So when you're finding the LCD, it's always based on the largest denominator. Now that may seem a little counterintuitive because it says least common denominator, doesn't it? But least just means the smallest thing possible, right? It doesn't mean the smallest number. It means the smallest possible number. Okay? So, it's always based on which denominator? The largest. And I'm going to give you two little cases here. First, if the smaller denominator will divide into the larger denominator, if the smaller one will divide into the larger one, So just look at your two numbers. You have 3 and 6, for example. 6 is the bigger one, right? Remember, it's always based on the bigger one. Will 3 divide evenly into 6? Yes. Okay, so that's what I mean by it will divide evenly into it. Then simply use the larger denominator as the LCD. The larger one is going to be the smallest thing they'll both divide into. But again, that only occurs if the smaller one divides evenly into the larger one. So let's look at a few examples. Now remember, your examples are going to be on the side. Mine are in the bottom because this thing's not wide enough for me to write them on the side. So say, for example, we have 5 and 25. Who cares? Doesn't really matter. And I don't care about what the numerators are because I'm just talking about the least common denominator, right? So my denominators are 5 and 25. Which one's the bigger one?
25.
Will 5 divide evenly into 25? Sure. Then what's the LCD for these two then? 25. You've got to use the bigger one, right? Okay, it's always the bigger one. So it just divides in. So let's say we had 4 and 12. Which one's the bigger one? Will 4 divide evenly into 12? So what's the LCD for these two? Yeah, the LCD is 12. Okay. Say we have 10 and 20. Will 10 divide evenly into 20? Sure, then what's the LCD? 20. Couldn't get much easier mathematically, could it? But if you don't know when to do it, that's what's the problem. Okay? So you have to know when to do that. How do I know to use the 20 as the LCD? Because what? 10 will divide into it. It's the bigger one and 10 will divide into it. How do I know that I need to use 12? Because it's the bigger one and 4 will divide into it. Yeah, and you know that 12 will divide into itself, right? Both 4 and 12 will both divide into 12. That's the smallest number that could happen to. Now, because if I have 4, does it work the other way around? Does 12 divide into 4? No, but 4 divides into 12. So that's why it always has to be based on the larger one. Okay? But does every number always divide evenly into every other number? No. So we need a second case. And that one starts off with if not. If not what? If the smaller one won't divide into the larger one, right? If not, then find multiples. Let me just erase that. I swear. Multiples of, which one is the LCD always based on? The larger. So which one do you think I'm going to find multiples of? The larger. It's always the larger one. Multiples of the larger denominator until you get something the smaller denominator will divide into. So the LCD is always based on the larger one. So when we're doing this, we're finding multiples of which one? The larger one, until we get something that the smaller denominator will divide into. So we're going to make the bigger one even bigger, in other words. Now when you're finding multiples, you might not have done this in a while, but when you're finding multiples, that means multiply the number by 1. You don't have to do that, right? Because it's the same thing you did. Multiply it by 2, then what? 3, then 4, then 5. So give me some multiples of 3. 3 times 2 is 6, times another 3 makes 9, times another 3 makes 12, times another 3 makes 15, etc., right? So multiplying times, I was doing exponents, I'm sorry, I'm lying to you. Times 5 is 3, times 4 is 12, etc., not times another 3. But, all right, so what we're doing is you're finding multiples of the number by multiplying it by 2, then 3, then 4, then 5, then 6, etc. Okay? So, but you want to do it in order. Because if you start jumping around, you might find a number that you think will work, but it may be too big. So make sure you're always doing them in order so you can get the smallest one possible. So let me show you an example of that. So 4 and 10. Will 4 divide evenly into 10? No. So I'm going to make one of them bigger. Which one?
20.
Yeah, we're going to make the 10 bigger. 10 times 2 is 20. Will 4 divide into that? Yeah, so the LCD for 4 and 10 is 20. Now, remember I told you about going back to elementary school tricks that work but aren't really good? This is a really bad one. Do not just take 4 times 10 and get what? 40. Now, that will give you a common denominator, but is it the least common denominator? No. And what if your denominators were 135 and 175? Do you want to multiply those two things together? No. You want to use the smallest possible number. So be sure to get rid of those shortcuts that don't really give you what you're looking for. Okay? So don't just multiply them together. Make which one bigger? The larger one. Okay? Say we have, I don't know, something over 5 and something over 12. No, that's a bad example. Hold on.
Let's have 3 and 5.
Okay, well, let's do that one in a second, though. I'm going to, but hold on a second. Well, let's just do 12. What the heck? It shows the same thing, but I really don't like it, but we'll see. All right, will 5 go into 12?
No.
So I'm going to make 12 bigger. 12 times 2 is 24. Will 5 go into that?
No.
Okay. 12 times 3 is 36. Will 5 go into that?
No.
12 times 4 is 48. Will it go into that? 12 times 5 is 60. Will it go into that? So the LCD for 5 and 12 is 60. Now it looks like I ended up just multiplying them together, but what I was really doing is I was finding multiples of 12. It just happened that the first multiple of 12 that would work is also 12 times 5. So you're really watching the pattern. 3 and 5. Will 3 divide into 5?
No.
Nope. 5 times 2 is 10. Will that work? Nope. 5 times 3 is 15. Will that work? Yes, because they'll both divide into 15. Okay? So you just make the bigger one even bigger until you get something that will work. Say we have 12 and 14. Now I could multiply 12 and 14, but is that going to give me the least common denominator? No. So I'm going to make one of them bigger. Which one? 14. Now, you're out of your comfort zone because most of us don't multiply 14s very often. But what can you do to maybe make your life easier when you're multiplying? Get your calculator out, exactly. All right? 14 times 2 is 28. Will 12 divide into 28? Nope. 14 times 3 is 32? 42, right? 42. Will 12 divide into that?
No.
No. 14 times 4 is, I don't know these numbers, y'all got to 56. Will 12 divide into that? No. 14 times 5 is 70. Will 12 divide into that? No. 14 times 6 is 84. Will 12 divide into that? I don't know. Y'all got the calculators. I'm just sitting up here. Okay. Will it? It'll go in there. So, what number do we have? 82? 84. What was it? I've forgotten. 84, I'm sorry. And 12 will go into 84? Okay. 7 times.
Because 14 times what?
6, wasn't it? Yeah, 6. Okay? So the LCD for both of them is 84. Now, just for kicks, who's got a calculator out? Do 12 times 14. What would that give you? 168. Would you rather use 84 or 168? Yeah. 84 is an ugly number, but it's not as ugly as 168. Okay? So always look for the least common denominator by making the bigger one even bigger. So, which one is the LCD always based on?
Larger.
The larger. Okay? Even though it says least, it's always the larger one. Okay. Now we need to talk about what happens after we find the LCD. Okay? Okay. If you change the denominator, which is the bottom one, right? which obviously, if we get an LCD, that means we've changed it, doesn't it? If you change the denominator, you must also change the numerator. Because 1/2 wouldn't be the same as 1/8, would it? Okay, or 1/4. Say you have half of a pie. That means you cut it into 2 pieces, right? But 4, this means you cut it into 4 pieces. Yeah? And one of those is not the same size as 1/2, is it? So if you change the size, which is the bottom number, the pieces you cut it into, then you also have to change the numerator, the top number. And this is where I'm going to show you that pattern that I want you to learn. Now, it's probably new to you. You might not have ever seen this before. It's been around for a long time, but you might not have used it this way. But if you'll take the time to learn it, we can expand on it and do a lot of different things. You'll see it used a lot in this course if you'll learn it. Here's the pattern. The first thing I'm going to do is tell you the name of the pattern. Because if you know the name of something, you're more likely to get there. Okay? The pattern is called divide, then multiply. You're going to notice that most patterns in mathematics or operations in mathematics are named after what you do. Okay? So, this pattern is called divide, then what? Multiply. So I have how many different operations going on here? 2. Which one comes first in the name of the pattern?
Divide.
So what do you think that means to do? Divide. That you're going to divide when? First, right. If it's divide, then multiply, that means you're going to do the division first. And then you're going to do what? Multiply. Okay? You've got to get them in the right order or it won't work. So divide, then multiply. And here's how it works. You'll take the LCD, which is the thing you just worked so hard to find, right? And you're going to divide it by the denominator. Now I'm going to put that in parentheses. And what does a parentheses in mathematics mean always? Do it when? First, right? Now when I do that division, I don't get the same number I started with, right? 8 divided by 4 is 2, right? You get a whole new number, don't you? And what you're going to do is you're going to take that result and then you're going to multiply it times your numerator. So there it is. Divide, then multiply. Do the division and then do the multiplication. Now here's how to make it work. First, rewrite one big, or just put right, don't rewrite, I don't know why is it. Write one big fraction using the LCD. Because I'm trying to put 2 or 3 fractions together anyway to make them one fraction, aren't I? Well, then why don't I just write it as one fraction in the first place? Does that make sense? Okay. And since I want the LCD to be my new denominator, that's what I'm going to use for the whole big fraction. Okay. Then, use the pattern. To change the numerators. What pattern? Divide then multiply pattern, you betcha. And then finally, combine the numerators. Combine means either add or subtract, depending on if it says plus or minus, right? Okay. And step 4, sorry it's on several pages, but that's okay, you have it neater in your notes. Step 4, reduce if possible. Okay? Because when we multiplied, as long as we reduced first, the answer was reduced. But this is not multiplying. We're making things bigger. And if you make things bigger, chances are then you're going to have to fix it in the end. Okay? So you're going to have to reduce it at the end.
Or step 3.
Step 3 was combine the numerators. Okay? Sorry. There you go. Sorry. Step 3, combine the numerators. So you're going to write one big fraction using the LCD. Then, if you change the denominator, which you did if you create the LCD, then you must also change the numerators by using the pattern. Right? So you use the pattern to change the numerators. Step 3 is you're going to what? Combine the numerators, and combine means either add or subtract, just depending on what symbol you have, right? And then finally, what's the last step? Reduce it if it will. Now, will they always reduce? No, but if it will, then you need to reduce it. So what I'm going to do is we're going to go right to your homework, excuse me, and we're going to look at some examples straight from your homework. So you know exactly what's going to be expected of you. Okay. All right. So the first one says to add the fractions. It's got 2/3 plus 1/15. Now, add the fractions. Right? They don't even see to add the fractions because they have an addition symbol. So here's what I would say to do. The first thing you always want to do is ask what operation. Because the operation is going to tell you what rules that you need to follow. So what operation is indicated here? Addition. But is this 2 plus 3? No. Yeah. What kind of numbers? What are these? Fractions, right? So these are fractions. Did I show you this little method of writing notes off to the side to describe what's going on? Remember, if you write it off to the side every time you do one, or at least the first 5 or 10, then you'll associate the step with the problem, and you make that association enough, and then it's just a piece of cake, right? Think about it. When you drive somewhere, you drive all the time. Half the time, do you have to stop and look at all the street signs as you go? If it's someplace you go all the time? No, half the time you get in the car, you go, and you don't even realize you've gotten there yet, right? You can make it a habit. Okay, and that's what you need to do here. All right, the operation here is addition. With what kind of numbers? Fractions. What do we know about adding or subtracting fractions? You have to find the least common denominator. Excellent. Okay. Will the smaller divide evenly into the larger? 3 divides into 15, right? So that means the LCD is the larger, the 15. So here's what this looks like, writing it as one big fraction. The LCD is 15. Just put one big fraction bar over there. And I usually write it right underneath, but I got a little off on this side, but that's okay. Now, if we change the denominator, we also need to change the what? Numerator. And we're going to use the pattern to do that. What's the pattern called? Divide then multiply. So, and I have 2 fractions, so that means I'm going to use the pattern twice. What if I had 3 fractions? I'd use it 3 times. So, okay, so here's what I want you to do. Don't be writing. I just want you to look what's happening up here first, because this is so easy. But if you're not paying attention, then you're going to look up later and go, wait a minute, where did you get that 2 or whatever, okay? What is my LCD down here? What is my first denominator? 3. 15 divided by 3 makes what? 5. And what am I going to do with that 5?
Multiply to 2.
Which gives me?
10.
And I just put that down here in the numerator. Plus, now let's do the other one. 15 divided by what?
15.
Is?
1.
Times?
1.
Is?
1.
Now, if it's not pretty obvious what you need to do next,
You just have to
just add the numerators, right? The 10 plus 1. So do you see the pattern? The LCD divided by the denominator, that result times the numerator. So 15 divided by 3 was 5, times 2 that's what gave us the 10. Where'd the plus come from? We just brought it down, right? 15 divided by 5 is 1. I'm sorry, by 15. 15 divided by 15 is 1, times 1 gave us the 1. Divide, then what? Multiply. Now what do I need to do? So 11 over what? Will that reduce? So there is your answer. So that's what you would do. 11 over 15. That's exactly the way you'd enter it.
We don't have
Okay.
to do like
No division because the numerator is smaller than the denominator. Now, what if it was 15 over 11? Then they'd want you to divide 15 by 11 and write it as a mixed numeral. Okay? But only if the top number is bigger than the small bottom number. Okay? All right. Y'all go ahead and write that one down? Okay. Now, the pattern never changes. The only thing that can change are the numbers that you use. So the pattern itself will not ever change. Look at another one. 7 over 11 plus 7 over 22. What operation do I have here? Addition with what kind of numbers? Fractions. In order to add or subtract fractions, what do you have to have? LCD. Will the smaller one divide evenly into the larger one? Yes. So what's the LCD?
22.
Yeah, the 22. Write it as one big fraction with that over the 22. But if I change the denominator, I also have to change the numerator using the pattern. Divide, then multiply. So what's my LCD?
22.
Divided by what? What's the first one? By the 11. 22 divided by 11 is 2 times what?
7.
Makes 14. Bring down your plus. Now let's do this one. 22 divided by 22 is
1.
times 7 is. Now what?
21 over 22.
And will it reduce? Nope. So that's your answer. It is easy. How many of you add and subtract fractions before? Really easily. How many of you think you can do it now? Yeah. If you learn this pattern, it is dead easy. Okay?
I got lost a little bit.
Uh-oh, where?
You divided 22
22 by 11,
by 11, which is the denominator again.
which gives me 2, right?
2, okay. And how do you know with the 14?
I multiplied what that times the 7, right? It's divide by the denominator, multiply what's left times the numerator. Mhm. You bet. Hey, sure, what's okay. Okay. So it was 22 divided by 11, right? Right there. Is 2. And then take that times the numerator, and that's how I get the 14. Right? Divide by the denominator, multiply what's left times the what? Numerator.
Do you do the
Mhm.
22 times 11?
Not times. What's first?
Divide.
Divide.
Okay, that's what.
So 22 divided by 11 is 2, and 2 times 7 gave me the 14.
22 divide
22 divided by 22 is 1,
on 1.
and 1 times 7 just stays 7. Okay? Yeah. The hardest part of this is make sure you know when to do what. What's the pattern called? Divide, then what? Multiply. Let's look at another one. 4 over 5 plus 1 over 15. What's the operation?
Addition,
Of what kind of numbers?
fraction,
Fractions. What do you have to have in order to add or subtract
at
fractions?
least common denominator.
Will the smaller one divide into the larger one?
Yes.
So 5 divided by 15 goes into 15, so what am I going to use?
15.
15. But if I change the denominators, I also have to change by using the pattern. What is the pattern?
And multiply.
Divide, then what? Multiply. What is my LCD?
15.
Divided by what first?
5.
Makes
3 times 4.
times 4, which is 12. 15 divided by 5, is 3, and 3 times 4 is 12. Bring down your plus. Now let's do this one. 15 divided by 15 is 1, and 1 times 1 just stays 1. Then what?
13 over 15.
Will it reduce? Nope. So there's your answer. Okay. All right. Now, again, the only thing that can change is that you can have a different operation, or your denominator may take a little more work to find. 2/5 plus 2 over 9. What operation?
Addition of
What kind of numbers? Fractions. Good. In order to add or subtract fractions, you have to find the LCD. Will 5 divide into 9?
No.
No. 9 times 2 is 18. Will that work? No. Times 3 is 27. Will that work?
No.
Times 4 is 36. Will that work? Times 5 is 45. Will that work?
Yes.
Yes. Okay. So I'll write it as one big fraction using that LCD. But if I change the denominator, I must also change the numerator using the pattern. Divide, then,
Multiply.
okay. So 45 divided by what first?
5,
Makes
9,
9. Times
2,
makes
18.
18. Bring down your plus. Now let's do the second one. 45 divided by what?
9,
Is
5.
5 times
2,
2 is
10,
10. Then what?
8,
Let's go straight across. You get 28 over what?
45.
Will that reduce? I'm going to say no. I don't think it will. So there's your completed answer. 28 over 45. Well, there are lots of different ways of showing this too. So most of the time you learn it up and down, and that's what I'm going to show you one right now. So 1/3 plus 1 over 9. This is the most typical way of writing, adding, and subtracting fractions. And most people would just then change them over here. I'm not. I'm going to use the same pattern that I've been using. Will 3 divide into 9?
Yes.
So the LCD is 9. 9 divided by what's the first denominator?
1,
9 divided by 3 is 3 times what?
1,
Is 3. Plus 9 divided by 9 is
1.
times 1 is,
1.
and that gives you 4 over 9. Will it reduce?
no.
No. Okay? So it doesn't matter how the format, if they can give you one on top of the other, it's still adding fractions, right? So okay? Well, all we did was, it was just written in a different format. And if you don't want to, you could have just rewritten it as, oh, sorry, I forgot I'm in the,
Oh, it's just a different way of.
yeah, just a different way of writing it. And if you want to, you can just go ahead and rewrite it like that so they all look alike, right? But it doesn't change the operation just because it's one on top of the other, does it? Okay? Yeah, that's what I want you to see. Now, will it change the operation if it's subtraction? Will it change the method, I mean? No, because adding and subtracting use the same method. What do I have to have first?
LCD.
What is the LCD for 9 and 63? 9 divides evenly into 63, doesn't it? So we'll use 63. But if I change the denominator, what else do I have to change? Using that pattern, which is divide, then multiply. So this is the first one. 63 divided by 63 makes what? Times
13.
is, bring down your minus. Well, let's do this one. 63 divided by what?
9,
Is
7,
times
1,
makes,
7.
then what?
Subtract 13 minus 7.
Which gives you?
6 over 63.
And I'm done, right? Now listen to the way I said that. What do you think? I'm done, right?
Yes.
Yeah, listen to the way I said it. You know I'm not done. Why do you think this one will reduce? They'll both divide by what number, do you think? They'll both divide by 3. 6 divided by 3 leaves you a 2. 63 divided by 3 is 21. And that's your completed answer. Okay? Now, some of you didn't see that 6 and 63 would divide by 3 because your division skills just aren't what they ought to be, or your multiplication tables, right? You don't know them, have them memorized. It's okay. So what I'm going to do right now, though, is I'm going to give you, because that's all the lessons for today, all we're going to do is add and subtract fractions, which is the hardest thing to do with fractions. Is it the hardest thing to do when you know what the rules are? No, it's easy, right? So what do you have to learn then? The rules, you bet. All right, I want to talk a little bit about division because you're going to be doing a lot of division here, reducing, etc., right? And I want to give you a couple of rules. I'm not going to go through a ton of them, but I'll tell you where you can find them. when you have division, division follows patterns. For example, how do you know that some number is divisible by 2?
Even.
It's even, which means the last digit is divisible by 2, right? So remember that. Most of us know that one. We know it's divisible by 2 if it's even. In other words, the last digit. Digit just means the little pieces, the numbers that make up the number. Okay? So the last digit's divisible by 2. Well, there's a rule for divisibility by 3 as well. Now, remember, digits are the numbers that make the number, right? That's what a digit means. What does the word sum mean to do? Adding them. It's the answer when you add, right? So if you add them, you get a sum. So if the sum of the digits divides by 3, then so will the entire number. So I'm going to write you down 2 numbers, and I want you to tell me quick. Don't think about the rule. Just tell me quick, which one will divide by 3? 111 or 112?
111.
Now, is 111 the one you would have chosen if before I showed you the rule?
No.
Which one would you have chosen? Probably 112. But it's really which one? Because 1 plus 1 plus 1 is what?
3.
And that sum divides by 3. What's 1 plus 1 plus 2 make?
4.
Will that divide by 3?
No.
Then neither does 112. Alright? If you add up the digits and you get a number that divides by 12, then the number divides by 12. Or 3, I'm sorry, not 12. Why did I say 12?
Let's say there are like 7 numbers.
Yeah, doesn't matter. 1, 4, 3, 2. I got to use small numbers or else I can't add them together. 1, what does that make? 5, 6, 7, 8, 9, 10, 11, 12. All right. Here we go. Here's a number. You like that number? Add them together. 1 and 4 make 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, what? 15. Will 15 divide by 3? Then so will that thing. Okay. Now, there are other rules for other numbers. I'm not going to go through all of them. I will go through 5. Why? Ends in what?
5 or 0.
5 or a 0 or a 0 and 5. Either way you say it, doesn't matter, right? How do you know it's divisible by 10?
0.
Ends in 0, right? Now there's a rule for 8, and there's a rule for 6, and there's a rule for 11, for 12, or there's a rule for 11, I'm sorry. But by that time, you should just punch it in your calculator and check. They're not good enough really to use like the 3 rule and the 2 rule and the 5 rule. But you should know the 3 rule. Okay? So you know a number divides by 3 if the sum of its digits divides by 3. Okay? All right. Well, that's it. Adding and subtracting fractions, what do you have to have? Least common denominator. Once you get it, if you change the denominator, you must also change the... And we're going to use that pattern, which is called... Divide, then multiply. Please, please, please learn the pattern. I'm telling you, it'll make your life easier now, and it's going to make your life a lot easier later when we start using the pattern for other things.